or talented. There are two persons in you. One is a good person, and the another one, I don't say that it is a bad person. It is a person that will trigger you to do things at this age. See, first of all, you should think of it for what purpose you are here. You all are having a very good future ahead. So this is the right place, VIT, the prestigious university where you are going to get your degree to enlighten your future. All the time you are not going to be a student like this. See, when I look at me in my earlier days as a student, maybe I too be like you. So at the same time, I do put myself, and I can say that my hard work made me to raise up to the level of director in a prestigious university. You also have to analyze you and see that what is good in you should come out. You should come out with your inbuilt talent. Enjoyment need to be there, but at the same time, it should not harm or affect us. There are some that we are making it mandatory. Say for example, wearing ID card. So I can see that many of you guys are wearing ID card, except a few. Why to wear ID card? What is the necessity of wearing your ID card? It is the identity that if you are not wearing ID card, I can say that you yourself is not showing you. That is, you are not respecting you. So tomorrow when you get into a company, so almost every company, multinational companies, it is mandatory that you have to wear your ID card. You can see when you go to Bangalore or Chennai or Mumbai, people wearing ID card even after the office hours. So many of you guys are hiding your ID card, putting it there inside the packet. Why you want to hide yourself? So you should be proud to wear your ID card wherever when you are on the way back to home. Because you are in a prestigious university. Tomorrow a day will come, that day you will tell, I am a VITian. I am an alumni of VIT. Now, what I am telling, you may criticize it, but after 5 years, after 4 years, when you get placed, that time you will realize the opportunity, only VIT will bring this opportunity to your life. So knowledge is very important. At the same time, self-discipline is also equally important. Only you become a complete man when you are knowledgeable, as well as you need to be discipline. So, with this, I conclude my words. At the same time, I wish the Data Science Club the best wishes in all its future endeavors. My dear students, what I am telling is not simply to tell. This is because for your betterment and for your better future. Please make yourself disciplined during your behavior inside the campus. I take this as an opportunity to convey what we, the VIT, is expected from you. Thank you.
Thank you so much, sir, for such inspiring words.
So everyone, get ready to accumulate heaps of data and knowledge.
Wait, Netflix saves about $1 billion annually on user retention, thanks to big data.
Oh, I see. Big data is the next trend. Okay, now let's get started. Today's first session will be Introduction to Data Science and Recommendation Engine by Sir Archit Jain.
The stage looks a little empty. Sir Archit Jain, who is a senior software engineer at Zorian Company, please have the stage and tell us more about data science.
Thank you, sir.
Volunteers.
Hello everyone. Hello. Responses. So how's your morning till now? How has it been till now? Any response? Nice. So it has been good for me so far, but we can make it better for both of us. I'm not here to teach you what data science is. Believe me, your faculty coordinators are good enough to teach you what data science is. I'm only here to bring in what industry is working on. I'm only here to bring in insights on what industry is working on. I don't want it to be a boring session. I don't want it to be a single-handed talk. It should not be a one-sided one. I would encourage all of you to interact, all of you to participate, make some noises, and we can get started with it. So before I continue, just a quick introduction about myself. I'm Archit. I have more than 6 years of industry experience into data science. I've done my BE from Indore, and currently I'm associated with Zorient Solutions Private Limited. So you can feel free to ask me any question, feel free to interrupt me at any point of time. I'll be happy to answer questions, and let's get started. So I'm sorry, I forgot to set the agenda. So anyone who knows what should be covered in data science, who knows what all topic to be covered, any suggestions, anything which anyone wants to give? Or I'll set the agenda by myself. Okay, so I'll start. I'll be covering what data science is. I'll be covering what process a data science project follows. I'll be covering who is a data scientist, what all roles are there in data science. Since data science is closely related with machine learning, I'll be covering some bits of machine learning, what are the industry use cases we are going on, and in the very end, I'll be covering a live hands-on workshop sort of. It's not exactly a workshop. I've built most of the material given time constraint, but then I'll be showing you what a problem statement is, how do we tackle it, and how do we solve it. So that sounds fine? Sounds interesting?
Yes, sir.
So let's get started. What is data science? The very basic definition. Anyone who wants to answer this? I have it prepared. I'm not asking for myself, but anyone who wants to answer it, who knows it? I believe you are students with me. I have fourth year students with me. Am I right? Only first year? Okay, let's vote it out. How many are third year? Raise your hands, please. Quite few. How many are from first year? Wow, the strength is huge. And are all the ones present computer science? Any another branch? If there's anyone, please raise your hand. No one? Wow, that's great. It would be easier for me to explain things now. So, what is data science? Data science is the discipline of making data useful. This is not a technology. This is not a technology. This is a field. This is a discipline of making data useful. When they were giving introductory sessions, they were saying that we have built so much of data. Every person is creating a huge amount of data every second. So we have data floating around. What we want to do, we want to make the data useful, and it's a discipline of making data useful. It's not a process, it's not a technology, but I say it's a discipline of making data useful. Jokingly, data science is also being called as statistics in fancy clothes. Believe me, that's how some people in industry refer it to. And statistics on a MacBook, not Windows. People want that data scientists should use MacBook. So, any questions on this? Data science is about making data useful. I know it's a very vague term. I know what I've said is very, very vague. Saying data science is just making data useful is too vague. But believe me, it's only about that, just in a complicated manner. And we'll see how complicated it might go to. So, anything? No, nothing. Let's move to the next one. So, what all the data science project's goal is? There are majorly three goals in a data science project. One is data analysis, second is statistics, and third is machine learning. Why do we use data analysis? We use data analysis to extract and convey insights from the data. We use statistics to establish causality. It's not casualty, it's causality. And machine learning to predict the future or to predict the missing gaps which we have there right now. So people usually think that machine learning would be used only to predict future cases, but it's not that. We have problem statements where we are having missing data. At points we would have to fill in that information, and to fill in that information we will use machine learning also. So in anything on these, a data science project wants to cover these three major points: data analysis, statistics, machine learning. Not everything would be there. You might have only one goal out of it, but then the goals might not differ from these. So I have very briefly explained what data science is. I'm not going to go in a lot of details. I'll bring in more of industry insights. I'm not giving a lecture here. I'm trying to bring what industry is doing. So I'll make these slides light. I'll not make it very difficult. So any questions till now on data science? I'm not going to go back on this. With the term data science, any questions? Has anyone any doubt? Everyone understood that it's just about making data useful? It's as easy as it is, but in a complicated manner. I'm repeating this. So data science life cycle. Does anyone know what data science life cycle is? What are life cycles of a project? Do we know this? No one knows about the life cycle of any project, be it data science or any project in industry. Okay, so I'll first cover that in a small term. We have multiple processes to do things. The most common ones are waterfall model, agile model. Waterfall model is a sequential. You got a requirement, you fixed it, and you start to build the solution for it. There are no amendments which you can do. But in agile model, you can do amendments multiple times. You get the requirement. That's how we usually work. We all, in our normal life also, we work in the same manner. We follow the agile methodology. Definitely your teachers would teach this in your curriculum coming forward, but that's just a simple term which I'm saying. A data science project's life cycle, usually we follow CRISP DM. I'm putting a big jargon in front of you, CRISP DM, Cross Industry Standard Process for Data Mining. Now, some of you might be thinking, you're talking about data mining, sir, but you're giving a talk on data science. But this is what it is. We use CRISP DM process to complete a data science project. This is the process which we use to complete a data science project. It has 6 sequential phases. The 6 phases are: first is business understanding, the second is data understanding, the third one is data preparation, fourth one is modeling, fifth one is evaluation, and sixth one is deployment. Now, since you can see, this is a continuous cycle. I'm not ending it anywhere. There's a continuous cycle which we follow. The continuous cycle starts with business understanding. You'll collect the requirement. What requirement is it from the client? The second would be, you would do the data understanding. So normally saying, if you have an idea in mind, you have a project in mind, what you would say is, you would first finalize what you are trying to do. Once you finalize what we are trying to do, you would start looking for the data. Do you have data for that? Do you have data for implementation? Is the data good enough? Do you want to cover more data? Correct? This is a to and fro process. You can have multiple iterations in this. You'll get a requirement, you'll try to collect the data. You don't have enough data, you have more than what you need. You might go back to business, you might say that we have this much data more, we want to cover this much more, or we are missing on this data, give us more insights, because business interference is very important. Until unless you know how businesses do things, you won't be able to do it. So business understanding, data understanding. One would be data preparation, would be modeling. Data preparation and modeling are again a to and fro process. You would do data preparation, you would do modeling. Your model might perform well, might not perform well. You would go back to data preparation, you will change things in data. You would again do modeling and then the process continues. After your modeling is done, you would evaluate it. Is your model good or is your model bad? If your model is good, you would take it to deployment. If your model is not so good, you might need more business insights for it. Simply saying, let me take a let me take an example. Let's say you are trying to build a recommendation system, a recommendation engine. You are working for Spotify, you are working for Netflix. We are continuously covered with recommendation engines. We are getting recommendations on YouTube, Google, Spotify, and Netflix, or be it anything. We are always getting it. If you don't know what data is to be used, you would first ask business that what should I use for recommendation? What data are you collecting? Once you have the data, let's say you have a clickstream data. A clickstream data is basically something where you are capturing every user's click, what all pages the user is visiting, what all content the user is seeing based on that. Once you have clickstream data, you will process it. You might get the data in structured format or unstructured format. Once you have the data prepared into the format which goes to modeling, you will do a model. Now you will try to evaluate how good that model is. Once you have the model evaluated, if it is good, it will go into deployment, or you will ask business, am I missing something? This is how I've done it. Am I missing a key information why my model is not good? And then this process again continues. So, any questions on this? Any questions, anyone? Wow, interesting. So let's simply talk about these business understanding. What does business need? You would get to know that there are software requirements, specification, documentations, and multiple things which are there. But then those all are not always perfect. What you need cannot always be conveyed. So business understanding takes a lot of time. The next one is data understanding. Then you look at the data, you understand it, you might get multiple bytes, terabytes of data, and you understand what is there, what not is there, processing all sort of information related data. Once you have the data, you prepare your data, you organize the data for modeling. So data preparation, data pre-processing. I'll stop here for a moment. It looks like people are not getting it very well. So first year students, do you know what data processing is, what data preparation is, how do we work with data? No? No one? Okay. Simply saying, if I've given you results for each of the student in separate documents, text documents, and you want to create a single result for the entire class, how would you do it? You would first club all the data together into an Excel file or something. You would create columns for your subjects. You would create rows for all the students. You would club the data. You would find the total marks. You would find what were the total marks out of, like, was there 500 out of which a student scored or something like that. And then you will create the result. So this is what data preparation or data processing is. You might get data into multiple different values, sources, but they will club together. You will bring it to a format with which you can finally work with it. So that's data preparation. Okay, so the fourth one is modeling. Modeling, what does the term model refers? Does anyone know it? Anyone have interest in machine learning, has read about it? What does the term model refers? No one? Okay, so the term model is very simply, I can say it's a recipe. Now you have all the data, you know how to do it, business has given you insights on how to do it. So it's simply a recipe. You have all the raw ingredients if you're cooking something, you know how to do it, you have assorted everything, you have put them in particular fashion that I'll first do this, and then you'll cook it. You'll prepare the dish out of it. So that's something is what modeling is. You're using a recipe to build something for which you had the requirement. That's what business wanted. So model is simply a recipe how the data would be processed. Fourth one is evaluation. What you would do is you would taste how it tastes. You would like to taste it. Is it good? Is it bad? You would evaluate the recipe. You would evaluate what you have done, and based on that evaluation, if it is good, you would finalize it. If it is not good, you would go back to business. You will say that this is not. Am I missing something? As an example, if you want, if someone mentioned you and you need to add water, did did you have to? So things can change. There might be very small details which you might miss, and then the process continues. So that's about data science life cycle. Any questions on this? I put a jargon that we are following crisp DM cross industry standard process for data mining. But then this is the diagram. This is the infographic. What is being used for crisp DM? This is the agile methodology. It's a continuously evolving one. You would follow this. Any questions? Has everyone understood it? Can we have hands for everyone who understood it? Okay, I can see some hands are not up, but they're not asking questions. Question? No? Any question on this? None yet? I'll go to the next topic then. An interesting one. Who is a data scientist? You're seeing a statement from Harvard Business Review, and that's actually true. That's actually true. So people say that it's the most lucrative job of 21st century. But now there are questions on this. If you search for this, you'd start getting headlines, you'd start getting taglines saying, is it still the most lucrative job? Is it still the most esteemed job? And there's a lot of debate going on around it. But can anyone say who a data scientist is? We have talked about data science. It's about making data. Now, can anyone say who a data scientist is? I'm sorry, two people were speaking at the same time. Only analysis? Organizes data, who works with data, who analyzes the data. Anything else? Brings out conclusions from the data. Anything else?
The one who helps the data to be used.
Who helps the data to be used. Okay. All of the answers are correct. All of the answers are correct. These all are roles of a data scientist. But then there are more roles for a data scientist to be played. As I mentioned, data science is a complex term. We make data useful in a complicated manner. The process is not so simple. I cannot just say that it's analyzing, it's managing, it's making insights out of it. We have multiple terms for it. A data scientist is someone who cracks hidden problems which are there in data. The person has to have knowledge of mathematics, statistics, computer science. These are the very basic things: mathematics, statistics, and computer science. But along with that, the person should have a very nice storytelling skills. Let's say you found out an insight and you're putting simply in terms in front of people saying, okay, I think we are missing 10% of revenue here. Does it sound interesting? No. But what if you go to a company and you would say, you can make $6 billion more per year by making this small change. That makes a difference. You need to know what is storytelling for a data scientist. That is a very important role of a data scientist. So you should know mathematics, statistics, computer science. Without these, you cannot do data science. But then there are some more skills which are needed. The core job of a data scientist is to understand data, extract useful information out of it, and apply this in solving problems. Any questions on this? Any comments on this? Anything which you like to add? Anything? Am I missing something? I've deliberately left a statement here. Can someone think of it? We do not talk about ethics at all when we are using data science. Ethics is also a very important part when you are playing with data. If you are not ethical, even use the data for negative things also. So you should be ethical when you are a data scientist. That is a very, very important thing. You would usually not find it across, but very often we come across situations where we are, we basically want to use something which is someone else's. We have data, somehow the data is leaked. It is available online somewhere. We want to use it for our good, not only about doing fraud online transactions and all, but in industry also, at times you might get some data which is available, but then you cannot use it. So being ethical is a very important part when you are playing a role of data scientist. No one can judge you. No one can judge you if you are ethical or not while you're doing the job. But then that's very, very important. So anything on this? Who a data scientist is? Is it clear by now? The person needs to know maths. The person needs to know statistics. The person needs to know computer engineering, computer science, because we finally need to work with algorithms. We finally need to build codes, solutions, which should be fast, which should be reliable. They should not fail. They should not have errors. They should be well deployed. Multiple things are there. But majorly, a data scientist should have these three roles. So I've covered what data science is. I'm not going to talk more on data science specifically. I've majorly covered what data science is, what do we do in data science, what is the process which we follow, the roles what are the key essential skills which data scientists should have. Now, how many of you know, because I use the term modeling, I use the term machine learning somewhere. How many of you know what is the difference between AI, ML, DL, and DS? First of all, the full form of all these four terms: AI, ML, DL, and DS. Anyone? Intelligence? There's some person.
Machine learning,
Okay.
deep learning,
Mhm.
data science.
And AI is for artificial
Intelligence.
So, are these the same term or are these different?
Different terms.
Different. How are they different?
ML comes under AI, DL comes under AI,
Mhm.
and DS also come under AI.
Are you sure DS is a part of AI?
No, I don't know.
Okay.
But ML and DL comes under AI.
ML and DL comes under AI.
Yes.
And how about, is DL a part of ML or only AI?
Both.
Both.
Yes.
Okay. About data science, so you are correct to an extent. But about data science, what is data science? Does it come under DL? Does it come under ML? Does it come under AI?
I think combination of three of.
Combination of three of them.
Yes.
Only three of them or two?
AI and ML.
Okay, so you are correct to an extent. This is the diagram. We have artificial intelligence as the very bigger area. Then comes ML, which is a subset of artificial intelligence. Then comes DL, which is a subset of machine learning. Deep learning is a subset of machine learning. And data science is a subset of ML and DL, but with some another methodologies also. Okay? Any doubts on this? I'll go through the definitions, but any doubts on this very simple statement: AI, ML, DL, and then DS is a subset which uses ML and DL.
Clear, sir.
Okay, so what is artificial intelligence? We are trying to create intelligent machines which can mimic human. What is machine learning? We are using statistics or mathematics to build recipes which can predict for something. What is deep learning? We are trying to build a complex mathematical model which mimics human brain, which mimics neurons, to basically store something in your memory and then predict for it. And then data science is a subset which uses ML, DL, and other methodologies to bring out key information out of it. Any questions on this? Any comments? This is very important. You would find a lot of people who do not know difference in these four terms, even when they are in industry. If they are not from data science background, if they are not from machine learning field, there are a lot of people who would not be able to do this. If you know this difference, you can actually make correct decisions towards your career path. So any questions on this? What path you want to follow, what career you want to follow? These four are different things. No questions? So we have talked about data science. We have talked about AI, ML, DLDS. The most important or not important, I'll say it's not important, but most of the roles in India particularly are machine learning engineers. Machine learning is the field which needs more insights, or people would ask you more questions on machine learning when you're out for interview. Even though if you're interviewing for data science, people would ask you majorly machine learning. Everyone knows statistics, I believe. Everyone knows statistics. You guys are in a very prestigious college. People know maths, but machine learning is something which you have not learned till yet. So let's talk about machine learning. What is machine learning? Anyone who knows what is machine learning? Okay, there's someone there.
Where an artificial machine learns from previous data it has received.
Artificial machine.
A machine and it learns from the data it has received.
Okay, correct. Any another simple definition if anyone has? There's a person here in the very front.
In machine learning, the robot or the machine learns from its environment to make further decisions.
It learns from its environment to make further decisions. Correct to an extent. I'm not saying it's wrong. But a simpler definition I want. Can someone give me a simple definition? A person does in the variant. For some reason, if this side is interacting, why this side is not? Am I not audible in this side? No responses at all.
Making the machine learn something.
Making the machine learn something. Okay, but do actually machines learn? My first question would be, do actually machines learn? We all are talking that machine is learning. The term itself says it's machine learning. But do actually machines learn? Yeah?
So giving a specific data to a machine multiple times so it can learn it?
Is it learning or only in a particular method, or is it only finding a particular pattern? Is it learning or is it finding a pattern? It's finding a pattern. This is a very important point. I'll be covering this in going further slides also. But machine learning is bringing intelligence to machine, not knowledge. AI technique that teaches computer to learn from experience. The definition here still says it's learning, but it's about finding pattern. It's not learning. Learning would bring in knowledge. The machines cannot have knowledge. Machines would just get the intelligence about a topic. Machine learning is a very, very directional one. Very directional one. Right now, if I'm speaking in front of you, I'm learning few things. I'm getting to learn how people interact. I'm getting to learn a lot of things. What is going around? What is not going around? I'm learning how to speak in front of audience. There are multiple things which I'm learning. But a machine learning methodology is very directional one. If I've made it learn to differentiate between a cat and a dog, it would only learn that. It would not learn that a cat has 4 legs and a dog has 4 legs. It won't learn this. It's very, very directional one. So machine learning is bringing intelligence to machines, but it's not bringing knowledge to them. How does machine learning work? There's a nice infographic. I've found this, or I'll say I've created this. That a person is saying that I can learn from experiences, can machine do? And the machine is answering, I can learn from past data, but I cannot learn from the experiences which I'm having. Actually, machines can learn from experiences, but then those experiences still become past data after just a given second or something. So it's saying that machines can learn, machines can infer based on past data. how does machine learning work? So a machine learning system learns from historical data, builds the prediction model, and whenever it receives new data, it would predict the output for it. Similar to how human brains gain, machine learning also relies on input, such as data or knowledge graphs, to understand entities, domains, and the connections. So the process, very simply, you have some data here, you give it to training, you give it to a machine learning algorithm, to a mathematical steps, defined sets of mathematical steps. You give it to, you give the data to it. We call it as training, a fancy word, training. But then you're just finding the variables there. Once you have all the variables defined, you would build logical models out of it. Models are the recipes, and then you would have output if you're giving a new data to it. Is this one clear? I'm not trying to go in a lot of depth. I'm not trying to bring in what your textbooks or what your textbooks already have. Your teachers would give you better definitions. I'm not bringing it here. I'm trying to bring in what industry would actually expect from you. So I think there's a question here.
Sir, suppose there are two algorithms for processing the data. One is suppose better than the other, like it's more efficient. But we give the more efficient algorithm less time to process the data, and the other algorithm more time. So will that differ the output?
Okay. What do you mean by efficient?
Like the algorithm is more accurate, like it will
Accurate,
process the
not
data more
efficient.
efficiently.
Okay. So see, you would have situations where I'm putting some words you might not know or you might know it. I'm putting names of some algorithms. You have a simple linear regression algorithm, or you have a random forest or a decision tree. Random forest and decision trees are known to give you much better accuracy, much better outputs, but then they take time. Whereas in linear regressions are something where you are simply trying to find a line which would try to fit in to what you want to train it, and it would give you answers very quickly. It would basically train very fast, it would predict very fast. So it sort of comes to what is the business requirement. If they want real-time answers, like let's say if you're doing something and then you want a real-time prediction, you might go for an algorithm which is faster but might not be so accurate. But if you want better results, you would do batch processing. You don't want the answer right now, saying that okay, it's okay for me to get the answer tomorrow, but then just give me the most accurate answer. In that case, you will use the algorithm which is more accurate but might take more time. There are researchers going around on reducing the runtime of algorithms, reducing the memory usage of algorithms. That is a very simple learning algorithms are broadly divided into four types: supervised, unsupervised, semi-supervised, and reinforcement learning. How many of you know these terms well? So I might skip it into very detail, or I might take it into very detailed terms. How many of we know it here? Hands. Does anyone know about this? There's only one person. Second, third. Okay, so I'll take it into a tad bit of detail. I'll not make it boring, but I'll try to explain it very quickly. Supervised learning is something when you know what you are being trained for. If I'm, as an example, if I'm putting in front of you images of a horse or a dog, I'm saying that this is a dog. This is a dog. This is a dog. We know a well-defined label. That is what is supervised machine learning. I'm actually supervising that you are learning that this is a dog. That is supervised. Unsupervised, where I'm not training you that this is a dog, but if I put in front of you images of a dog and cats, you learn to differentiate what is a dog, what is a cat. Correct? So that is unsupervised. You do not know the label, but you just, based on similarities or dissimilarities, you are trying to segregate them. You are trying to find clusters out of it. Third one is semi-supervised. It gets covered in two types of machine learning in some places, and some places they are not there. Semi-supervised is basically a technique which is a mix of both supervised and unsupervised. What if I taught you based on only three images that these are dogs, based on three images that these are cats. Now you want, and I've given you a task to basically segregate hundreds of images. You cannot learn only from 3 images. Then you are continuously, based on 3 images, you have learned something, and then you are using unsupervised learning algorithm to first segregate out, to first cluster out or segment out all the dogs together, all the cats together, and then based on your learning that okay, these 3 were dog amongst these, so these 3 are dogs, and these 3 and these are the cats because we have 3 cats here. So that is semi-supervised. This is a very interesting thing. Once you learn more about machine learning, this has a lot of use when you do not have enough data for you. When at some instances, you would see situations where you don't have enough data labeled. So this algorithm is used for labeling and training both. Labeling isn't to say that this is a dog or this is a cat. That is labeling. So you would have situations where you do not have labels. A person would have to manually create a label, and then that is an extensive process. So you would create some segments, you would use unsupervised learning and then supervised learning to create the data out of it. Fourth is reinforcement learning. Autonomous systems, autonomous robot, self-driving cars, self-learning system, AI learn how to play Flappy Bird. All of these things, these are reinforcement learning. A system takes a step, it sees that was it a good step, was it a step. You are continuously getting feedback there. Let's say you have a game score. The game score either increases or decreases. So you have a game score based on what step you are taking, in which direction you are moving. You would either get a positive feedback or negative feedback, and then the machine reinforces its learning. If I'm moving closer towards is rising, so the machine knows that I have to move in this direction, and if I've crossed my goal, let's say there was a goal to go down these stairs, and then if I crossed it, so I'll get a negative feedback. I might fall from this podium, I might get bumped into a wall. These all are negative feedbacks. So machine is reinforcing where it should move. That's reinforcement learning. Any questions on this? Should I take a simple example? Yes, it was difficult. Supervised learning. I'll first go with unsupervised learning, okay? If there's an infant, a very small kid, 6 months or so, you have put medicines and his favorite candy in front of the infant, not his or her. So you have put candies and medicines. Does that kid know what a candy looks like or what a medicine looks like? He doesn't know what is candy, what is medicine. But based on similarity or dissimilarity, he can segregate them. He can put all the candies together, he can put all the medicines together. That is unsupervised learning. You don't know what it is, but you can use the similarities or dissimilarities to create groups. Simply saying, you have balls and you have balls and maybe some rectangles. You have balls and rectangles. You can put them into different jars or bins. That is unsupervised learning. Supervised learning is something where you know what is a candy and what is a medicine, and then you are using that knowledge to basically differentiate between them. That these all are candies, these all are medicines. That is unsupervised learning. That kid has grown up to maybe an age of 2 years now. Now that kid knows very well what is a candy and what is a medicine, and he would choose, or he would say that this is a candy, I want this, or this is a medicine, I do not want this. Now, while that kid was getting to an age of 2 years, he used semi-supervised learning. At the very first instant, he only knew what is a candy. A single candy he knew and a single medicine he knew. Then he used his knowledge that these all look similar. These might be candies. These all look dissimilar, not so same. These are medicines. And then he used that knowledge to actually say that okay, all these are medicines, all these are candies. Got it? This is a simple example. And then the same infant, when he learns to walk, the infant is learning to walk or learning to run or trying to climb stairs. The kid will fall multiple times. The kid would get bumped into walls multiple times. And then there he is getting a positive or a negative feedback. Should I not do this? That's reinforcement learning. No one is teaching him. No one is supervising, or he may not be able to differentiate, but then he is learning, he is getting feedbacks. That is what is reinforcement learning. Is it clear? Any questions on this? No? I'll quickly cover use cases on this also. Supervised learning is used for classification and regression problem. Classification is saying that this is a boy, this is a girl, there is a candy, this is a medicine. Regression is saying how much marks you can get, what is the price of a house, things like this. Okay? In unsupervised, we use it for clustering, as I said, to separate out all the candies and to separate out all the medicines. It can also be used for anomaly detection. If an anomaly comes, amongst a jar of candy, if a medicine comes, that kid can tell that this is something different. I don't know what this is. This is an anomaly in my jar of candies. Understood? Semi-supervised learning mostly used to build new label data. Let's say, as I mentioned, the kid knew 3 candies and 3 medicines, but he wants to label, or he wants to say all these are candies or all these are medicines. Give them name that there's a candy, these are medicine. That is what supervised learning is. And reinforcement learning is simply used in autonomous systems like a self-driving car, a path-following robot and things like this. Not exactly path-following, but a robot who can walk in a particular area, or a system that can play a game. Okay, clear? Any questions on this? No questions? This is almost a chapter which I've covered here. Any questions on this? Okay. Which one to use? We have talked about 4 different methodologies. Which one to use? Can anyone give me examples, not what I have given, but let's say if there's a business use case, or if I'm saying that you want to decide if someone needs to be given entry to this auditorium or not, what would you use? Yeah? Why supervised? Sorry, I couldn't hear you. Okay. Can we have a mic here, please? In the very front.
Because the person should be registered first before entering the auditorium.
Okay. Okay. Any other responses? There's a very important point I would raise here.
Sir, unsupervised.
Why unsupervised?
Sir, because it is an anomaly detection. Because if the person is not registered, it will come out of the relationship that we have discovered.
Okay. Okay. Let's quickly go back to CRISP DM, the process which I was saying. Do you guys? Okay, you know what is the business understanding. You want to know if a person should be given access or not. Did you ask yourself, do I have the correct data? Do I have enough data? Did you know that the person is an outsider? You both mentioned that we know that the person is not in the list. Did you have the correct data? No, you didn't have the correct data. Unless you have entire information, you cannot decide that you should use a supervised learning algorithm or an unsupervised learning. Now let's think that we have that label that the person has registered or not. Registered, not registered is a label on which supervised machine learning algorithms work. So that is something based on which you can decide if a person should be given entry or not. Another example, if the person is not wearing an ID card of VIT, you do not know what an ID card of VIT is or if it is legit or not legit. But then based on ID cards, you can segregate that person that you do not have an ID card. You look to be an anomaly here. You should not be given entry. Understood? We have both the cases. We have supervised and unsupervised, both the cases here. Is that fine? A very complicated diagram. You all can just have a look at it. I'm not going through it. It's a complicated, not complicated, it's a simple diagram to explain, but then it's too much of information. So I'll sort of skip it. The very first talks about, in very simpler terms, there are 2 green boxes which talks about your questions. Do you know the natural data dimensions? Do you know if a person is registered or not? If you do not know, go for unsupervised learning. if you know the person is registered, do you know what all the situations are there? You have basically two methods: an active learning system and passive learning system. Active learning where you are learning continuously, passive learning where you have a data and you have learned based on it. You already have a registered participants list, that is passive, and you are giving entry or you are seeing VIT's ID card and giving entry to people, that is active learning. So if it is active learning, that goes to reinforcement learning. If it is passive learning, that goes to supervised learning. And then there are multiple situations. I'll not cover that because that would be too much of information, I believe. So, seen what machine learning is. We all have heard we are covered with machine learning continuously. Have we find a genie which can solve all of our problems? Do we have multiple or unlimited wishes which a genie has granted us by machine learning that we can solve anything or everything? No? No? Is machine learning perfect? Can you solve anything or everything out of it? No? Are you sure? Because you are continuously covered with machine learning everywhere. Is it perfect? Can you solve everything? No? Okay, so you all are correct. Machine learning is not perfect. It is important to understand what machine learning can do and cannot do. As I said, machine learning is only about getting some intelligence. It's not about getting knowledge. Okay, so it cannot do anything or everything. It's very directional. What you have asked the machine to learn, is it a cat or a dog? It would only learn that. It would not learn that a cat and dog both have four legs and cat and dog both have a snout, both have 2 ears. It's not going to learn this. Generally saying that they all have four legs and all. There are always exceptions. Challenges with machine learning. Too much of information, do not try and grasp all of it. I'll make it very simple. Machine learning is not based on knowledge. As I've repeated this 2 or 3 times, machine learning models are difficult to train. When you will be reading materials, when you would be seeing YouTube videos, or following blog posts, doing Kaggle problems, it would actually sound to you, or it would feel that machine learning is very easy. But I have the statistics. 81% of data scientists admit that machine learning models are not easy to train. It's not simply doing a dot fit and dot predict function in Python. It's not so easy. Machine learning models are prone to data issues. 96% of companies are saying that we still have data issues with the models which we have. Although they might be in deployment, but then there's still scope to improve it. And it's often biased. Bias. What does the term bias mean here? Can anyone tell me? Bias. Someone?
Partial, not based on not fully known data.
Partial based on not fully known data. Okay. Anyone else? I want an answer from this side. Anyone from this side, please? No one. Okay, so you are correct to an extent. Bias means partial. Partial, but not exactly that you do not know the entire data or something like that. Simply saying if you are trying to predict credit card frauds, there are millions of transactions which are legit, and then there would come one fraud transaction. So your machine learning system would actually start predicting everything is legit and not fraud. So that is where the biasness comes from, and it is very difficult to overcome this. So these are some of the major challenges of machine learning. Let's get back to data science. What are the applications of data science? All of the theory is done by now. There's no more theory. Now let's make it more interactive. What are the applications of data science? Where can we use data science? Anyone? Business analytics. Okay. I'm more talking about industry terms. In any industry, you know. Recommendations, but it's not still industry specific. It's a use case specific. That person.
Inventory.
Inventory
Management.
Inventory management. Okay. Okay. Anything else?
Healthcare.
Healthcare. Okay.
Marketing.
Marketing, nice.
Search engines and advertising.
Advertising, again a part of marketing. So data science, regardless of any industry, any vertical, can be used in anywhere and everywhere. Data science, regardless of any industry or any vertical, can be used anywhere or everywhere. We are creating huge amount of data which we do not know is so much of useful that we can actually make a huge impact. I'll give you an example. I came across someone in the industry, a good friend of mine. That person did a project of only 1 month. Only 1 month. But that person made a difference of 6 billion US dollars. Can you beat that? 6 billion US dollar per year by just a simple project of 1 month, because that person knew that we have the data and we can solve this. Where people are investing years of efforts manually doing that task, and people were thinking that we do not have the sufficient data. You simply need to play with data, be it any industry, any vertical. I'm talking about an automobile sector where I know this, but then that is an actual use case. In automobiles, we can use it. There are multiple sectors present here: marketing, healthcare, credits and insurance, sales, travel, social media, automation. There are multiple. These are very few of them, but then there are multiple. Any questions? Any question which you have in mind, like Archit, we used in this particular case? Anything like that? Anything in your mind? No questions? Okay. Where to start? Interesting part. Now people would have more interest. Where should I start learning data science? How many of you know what? I'll cover it quickly. To learn data science, the most widely accepted technologies are Python and R in terms of languages. Since I belong to the community where we use Python more, you have packages like Pandas and NumPy to make mathematical computations. These are for data processing and stats. You will find almost all the statistical functions present there, be it any distribution you want to find, be it quantiles you want to find, be it anything, you would find it from here. Machine learning libraries such as scikit-learn, TensorFlow, Keras, these are some of the libraries which basically gives you simple functions. Nowadays, machine learning is so simple, you do not need to write mathematical equations. You simply need to bring in an algorithm, just say dot fit and give the data to it. That this is the data, take it and just learn it. Definitely, it is complicated because you need to tweak a lot of things. But a very simple model can be trained by just using a dot fit function, and then a dot predict would predict for it. It's so simple nowadays. But then tweaking it is the difficult part. And then there are platforms like Kaggle, Google Colab, where you can do things if you do not have the resources. If you do not have a GPU to train, you can use Google Colab. You can use Kaggle to access a lot of resources. There's a lot of data available there. There are codes available from people, if people have made it public. You can have a look at code and you can see how that person is achieving 99% accuracy, but I'm stuck to only 60%. What is wrong which I'm doing here? So do read these resources. The Bible of machine learning is Machine Learning by Andrew Ng. Andrew Ng is the father of machine learning. He is being termed as father of machine learning. This course is available on Coursera. I believe it's a top rated course amongst Coursera. You can have this course. It is a very nice course. That person goes into detail to the simplest mathematical equations. He would actually solve that in front of you and would teach you. So this is the course which everyone should at least have a look at once in his career if he wants to understand what machine learning is. And then I personally do follow blogs. There are a lot of YouTube content there. There are a lot of content available. But I personally follow blogs, so Towards Data Science and Medium.com. These two are very good blogs. You can at any point of time read them. So we understood what data science is. What is the role of a data scientist? Where should we start? We all know this is a very lucrative job. It's a high-paying job in this industry, in IT field. So, where do you fit in data science? Do you know what all roles are there in data science? I did mention that a data scientist should have maths, statistics, computer science. He should know how to handle databases. He should know how to tell story. He did a good job, but if he doesn't tell a good story, he would not be good. So there are multiple roles in data science. Data scientist itself, data analyst, as someone from here mentioned, data science is about analyzing the data. So data analyst is a separate role. Data engineer, a person who handles huge amount of data, makes pipelines to quickly transfer data from one place to one place, to quickly process the data, prepare the data. That's data engineer. Data architect, person who knows how to handle data well, be it transferring, be it storing, be it anything. So that's data architect. ML engineer, a person who specializes in machine learning, algorithms of machine learning, concepts of machine learning, how to tune machine learning algorithms. That's ML engineer. BI developer, business intelligence developer. This person is someone who knows the business in and out. You would, if you follow BI developer, you would actually make it more directional that you want to specialize in this particular industry, be it retail, healthcare, be it something. And next is database admin, because you need to play with data, you need to store it. Some use cases which we are solving at Zorient. So I belong to Zorient Solutions Private Limited. There are multiple use cases which we are solving. These are some of the projects which we are pursuing at Zorient at this moment. One is OCR-based content extraction. So do all of you know what OCR is? Does anyone know? Just raise your hand. Okay, there's only one person who knows. We are short of time, so I'll not cover this in very detail, but OCR is optical character reader. You're just trying to read or get text from images and all. So you might have tried, you have an image, you want to extract text, you are lazy to write it, so you look for OCR online. There are multiple OCRs available. You just paste your image there and you'll get the text out of it. It may not be perfect. So we are not simply doing this, we are finding a specific information from a document. If you give a document of maybe 10 pages, 15 pages, 20 pages, or be it so, usually the use case is to find a particular key information, be it available on any page. Second is predicting sales by each customer. So it's easy to predict how much money a business is gonna make, but it's very difficult how much sales each customer is gonna make, because each customer is different. You might like the brand, you might not like the brand. You might purchase only in holidays, you might purchase only in discounts, you might like something, you might not like. So there are multiple cases, every person is different, and then tapping what each person thinks is very difficult. So that is predicting sales of each customer, recommending products to customers, recommendation engines. This is also one very interesting part. IoT-based predictive maintenance. Would it not be good if you already know that a particular machinery in a big plant is going to fail, and you can do predictive maintenance? You can already maintain it so that it doesn't fail and there's no stop time for you. You can make more money, you can generate more products. Time series forecasting, very simple, predicting what is the weather. But then this particular is also used widely in industry. It's not so simple. The last one is image processing. To process the images, there are multiple use cases. Because of some reasons, I cannot exactly say what the project is. But then we also work in image processing. So, okay, I'm done with my content here. Now I have a hands-on use case, but first I'll give you all chances to ask questions. Be it about data science, be it about industry, be it about how to prepare for your interviews, be it anything. It's an open forum. And if there would be no questions, I would go to a very small code and I'll show you how it's being done. So first of all, you guys have an option to ask any question about resumes, about interviews, about what should I learn, I have this knowledge, what should I learn more, anything? Oh, Okay, so my question is, does the background matter in this industry? Can you please elaborate? A background in the sense the computer science background or anyone with the knowledge can enter in it? Anyone with knowledge can enter. Okay. Your background does not matter that much. It do matter. It does matter. But then it's not a hard stop for you if you are from, let's say, mechanical engineering background. Okay. I'm giving an example. You know how machines work. You know what are the faults a machine can bring in. Maybe a vibration is increasing, or this particular pattern of vibration, or if this particular pattern of things happen, that then the machine is about to fail. You have that business knowledge which you can put in into data science. Okay, so background doesn't matter. Definitely you would have to learn few things, how basic computer science algorithms work, how basic computer science projects are being done. But then it would be good if you know the business in and out. So you can work as a business BI analyst, sort of, not exactly BI analyst, but someone who specializes in business and can bring in that knowledge so that people can better direct their efforts. Okay, thank you. I was expecting a lot of questions on this part, that how to prepare resume, what to learn, what things are being asked if I'm being interviewed for a machine learning or a data science engineer.
So you mentioned that the privacy of customers is important.
Mhm.
So how do companies ensure this when ethics are here?
So
Data
first of
science.
all, when a company stores data, that's ideally not accessible to anyone outside the organization. Not even outside, inside the organization also, you would have restrictions on tables or databases which are accessible. So that is one thing. The data which is stored is usually encrypted, is masked, so you would not know that. Uh, we Companies usually hide the personal information, PPIs, personal private information, be it your Aadhaar card number, PAN card number, social security number in US and all. So those are usually encrypted, those are masked, so you do not get access to this. These are the basic things which is being covered into security of your data.
And is there any time period for which the data is stored, or is it like stored forever?
It goes from business case to business case. Uh, Zorient, in Zorient, we are service-based person. We get a project. The project is done for a timeline. Usually, we get access to the databases of client till the time the project is going on, till the time we are connected with them, the time we have our SOWs signed, we get access to their environment. As soon as we are done with the project, our accesses are revoked. So that's how that organization is maintaining data integrity at their end. If we have downloaded some data, if there was a use case that I need it on my machine, we usually make sure that we delete the data which is very sensitive.
Thank you, sir.
There's a question here.
Good morning, sir. How much time does it take to become an ML engineer if I start from now itself?
How much time does it take to be an ML engineer if you start now?
Yes, sir.
How much time are you going to devote?
So probably 6 to 9 months rigorously.
No, per day or per week. Can you devote 2 hours, 3 hours per day, or
Yes, sir.
or 7 to 8 hours per week?
Yes, sir. Quite feasible.
You can easily be an ML engineer in 6 months to 1 year. Depends on what use cases are you solving. You start with end-to-end machine learning course. It's, I believe, a 2 or 3 months course. You would get basic information of all the machine learning theories, all the machine learning algorithms, solve problems on Kaggle, read what people are doing on blog posts, watch YouTube videos. You would have good enough information to basically maybe pass an interview on machine learning for a fresher. That simple. It's that simple. It's just that with experience you will get insights that you need to think innovatively. You will get that insight once you have experience. We do not expect it from a fresher that he would come up with very innovative solutions. That's the only thing.
Sir, what is a strong resume?
A strong resume.
Yes, sir.
Personally saying, if you ask me, I do not rate people on resumes. What have you written in your resume? Do you know that well? That's it. For me, a strong resume is something where in which the only content is what you know in and out. If you don't know something, just don't write it for sake that it should have been there. If you don't know databases, but everyone should know database. I'm a BTech or MTech student. I should know database. But if you don't know it, I would say not to write it. Or if you know only the basics, say that basics of databases. Because if you write databases, you might get an opportunity to work in that field, but then the interviewer would actually reject you because you don't know it well. Your resume should reflect what are your strong points. That's it. That is a good resume. Thank you, sir.
Is scikit used in the industry level?
Yeah, scikit-learn is widely used in industry. There's I believe there should not be any industry or any particular organization which is not using scikit-learn. In one way or the other, people are using it.
Good morning, sir. Generally, when we are appointed as a programmer in any company, we generally expect that we have to code and run. What can we expect when we are appointed as data scientist?
Okay, first of all, it's highly unlikely that a fresher is being appointed or is being taken into an organization specifically for a role of data science. Very few industries do that. Okay, so usually everyone gets recruited based on what his resume is there. They might give you any job, but if a profile focuses more on machine learning, data science, you might get that role. It's not 100% compulsory that you'll get it, but if you get it, you would have to write codes in Python. The very basic starting would be to write codes in Python to train basic machine learning models to do data preparation. Definitely, there would be someone supervising you to give you insights, but this would be the starting point. You won't get the ownership to train a model by yourself if you are a fresher. It's very difficult that you'll get that. But you would slowly and slowly, you would be there in projects. It's not that you would not be there in projects. You would get all the accesses, but you won't have the responsibility or the ownership. That's it.
Thank you, sir.
Good morning, sir. So my doubt is like when we are building a resume. So when we build our resume, what should we should emphasize on, like the courses which we have done, or the projects or the experiences, like when we go to third year, we do that internships and all. So which should be our maximum priority?
Projects. Do whatever project you're doing, you might be building two projects, minor and major. Make sure that you know your project in and out and you actually utilize that project. If you have a time of 1 month to do a project, please utilize 1 month, not just a week or 2 days for it. In terms of project, generally speaking, I would say if you are following machine learning or data science, please refrain from using the very basic use cases like housing price prediction. There's a very common data set about flower. Is it Iris or Sentosa? So do not mention them. Do not use them. These are so common. Everybody knows that. Everybody. If you want to stand out, try to bring in some new use case. Think of something else, create your own new data, but do not use the most common available in your projects and in your resumes because that's not gonna make you stand out.
Thank you, sir.
Sir, how data science is different from data engineering?
Data engineer is responsible for creating pipelines so that data flows. So let's say if you have access to an environment where you have thousands of tables, if I have asked you to create a single table which would have all this information, the single table would have data in terabytes. Okay, so if I ask you to write an SQL statement, it might take 1 day, 2 day to run. But then data engineer knows how to do it efficiently. The data engineer would utilize Spark clusters, would write ETL jobs and things like that. So that person would only be dealing with how data is being maintained into database systems, how the pipelines are set and things. But data scientist is expected to know basics of all and majorly work with maths and statistics and machine learning.
So can Zorian solutions be trusted?
Why not?
So like for example, if we take the example of Facebook, the information was breached. And if we take example of our university only, like past 2 or 3 days back, the email was hacked of the university. So can Zorian solutions be trusted?
Why not? Every company is putting up a lot of money in security. And as good as each organization is, every organization has data security or data privacy as the utmost priority. So it is definitely trustable. There's no case that your data is going to be breached or any such sort of thing happens. Not only with Zorian, but generally speaking with any organization, because that's the utmost priority of all the organizations right now. And then since you're saying that Facebook's data got breached and all, so always a loophole might be there, which the organization also doesn't know, but somehow people exploit it.
So, but can we make the system a bit more powerful that the chances of getting the data breached become less?
Everyone is trying to do that. If you go, cybersecurity is an entire field in itself. People are putting a lot of effort in making systems more and more secure. So no one is giving any chance. It's just that some new person might come with an exploitation method which he has developed as a very new thing, or then he came across a loophole which even the organization didn't know. That's the only case when your data might get breached, or if there's someone internal who does this. There's nowhere apart from this.
Good morning, sir.
Good morning.
My question is, how is cloud computing and data science related?
So right now what is happening is people are actually moving from internal server-based systems to cloud, because cloud gives us so much of flexibility that you can bring in any sort of computation power there. If a company has to do a GPU-based task, if I'm training a very heavy model or a very complex one, I would have to purchase a GPU. But on cloud, you can rent it out. If your project is of only 6 months, why to purchase a whole GPU itself? You can rent it out for 6 months. Similarly, nowadays cloud is also giving a lot of automated process, no code machine learning, no code data science. So there are a lot of packages which are built around this, where you can almost leave all the hassle behind of writing codes, and you can do all of these. But then those are not so perfect, since those are black box things. You do not know what is going on behind, or you are not able to tweak it. People are more relying on the traditional way of building models at this moment. So that's how cloud computing, we are putting all of our data on cloud. We are using the clusters on cloud, which we rent out, with the machines which we create on Amazon, AWS or Azure and GCP, and then we use that, because not every data scientist can have a GPU on his machine. That's very costly. That's the reason. Cloud computing is right now very closely related with data science.
Will in future can it be related, or will there be more application of cloud computing in data science in future?
Yes. Definitely nowadays when organizations are hiring, they are looking for one of the other cloud, be it AWS, be it Azure, be it GCP. That's sort of a mandate at this moment, that a person should know one of these cloud platforms. Not entirely, but what is related to data science, at least that much.
Good morning, sir. Sir, what is the difference between big data and data science?
Big data is very closely related to data science. It's not that it's completely different, but in terms of big data, you are talking more about handling terabytes of data, maintaining it, storing it, bringing in security and things. Data science is only about extracting information out of it. A data scientist or a person in data science is not so much concerned that what is the security which is there on database. That big data person or database engineer or those persons are there to take care of that. When you're working with very huge amount of data, not predicting but maintaining the data by storing it in more efficient manner, by creating hot or cold storages, Those things are usually taken care of in big data term at this moment.
So it is a bigger term for data science.
Not exactly. Big data people would not be able to predict, would not be able to give you insights. That's not their core job. Their core job is about giving you all the transactions on time, creating all the tables which are important, make sure that databases do not go down. All of these things are taken care, but they are not the ones who are responsible for giving you insights or for predictions. So they all work together, and that's how the projects get delivered. If there are no more questions, I'll take this as the last one.
So, Power BI or Tableau?
I cannot say with Tableau also. There are pros and cons for both. It's not that only one is good or one is bad. There's no such thing. Power BI is more widely utilized because Microsoft's ecosystem is so good that people utilize Power BI more at times. But Tableau is also widely utilized. I'll not say that it's not utilized that much. Projects where we have utilized Power BI, there are projects where we have utilized Tableau. It majorly depends on client usually what they want to implement. There's also ClickView. So there are multiple systems like this: ClickView, ClickSense, Power BI. You'll get to know. I'm not sure if that library is available in R and MATLAB too, but people have built a lot of libraries, a lot of packages which can be used easily. So should we go quickly to a use case? Do we have 10 or 15 minutes? We have? Okay. Hello? About a use case which is simply saying that how much revenue a customer can bring in for the organization. I talked about this in the projects we are solving at Orient. So there's a use case, this is an example about it, that how much money a particular customer can spend with you. What do we need for this is we need transaction level data, or we had it. I'll not say we need it, we had it. We had transaction level data, how many transactions each person is doing in his lifetime with a particular client or with a particular brand. So this is a data which I've got from online source. I've masked it. I've changed some things here, and then I'm showing a very simple example. What transactions do I have for each customer? What price item did he purchase? So what was the net price the item was purchased at? What was the retail price? So retail price and net price, the difference is that the actual MRP is retail price. The price on discount which you have purchased it is net price. How much quantity you have purchased, sale type, what is a sale or a return. You might get returns also which get logged in the transactions data. What is the product brand which you are getting, what is the product type which you are getting, product number, what product you have purchased. Brands and type cannot always talk about the differences between product. The product gender, was it a women's product, men's product, boys, girls, or unisex, or is it product or is it gender independent, and the transaction date. So this is a typical online transaction data which you can find somewhere. Any questions on this? Nothing very fancy here. Just the transactions which are there. What I did is because of time constraint, I have created an attribute data. So what I'm doing is attribute data is basically aggregating all of the information for each customer and then creating some features out of it. I can get some features of users here that for each customer, for each buyer, what is the recency frequency monitoring. Now, the problem which I'm solving, that I have to predict how much money a customer is going to spend, is termed as CLV. The jargon for it is CLV, customer lifetime value. What is the value I'm getting from this customer in its lifetime with this particular brand? Okay, so I put a jargon CLV. I might use this continuously. So it's just that how much money the customer is going to spend with our brand. So recency, how recently the customer comes to our stores or to our online store, anything. Frequencies, so frequency is how frequent he comes. Recency is how recent he visited the store. So that gives us an information. If a customer did not visit us since 3 years, we believe that the customer is not gonna interact with us or not gonna do transactions with us. Monetary is how much money the customer has spent with us till date or into a particular time frame. How many number of transactions he did. So visiting a store and purchasing 5 products. So visiting a store is trip, or your recency and frequency is based on that number of transactions you have done in that trip, or that particular visit is your number of transactions. Gross monetary value is basically if there was no discount applied, what would be the purchase you would have done. Monetary value is with discount. How many, because I had data here of brand and product type. So I've talked about simply saying what are the number of brands I'm purchasing, what are the number of products I'm purchasing. So unique number of brands, unique number of products. Active or churn. So this is a nice thing. Active says that would a person be still purchasing with us. Churn says that the person is likely not to purchase with us in future. There would have been cases you might have been purchasing from a particular brand, from a particular shop, but on a particular day you stop purchasing from that shop and then you start purchasing from a different one. Okay, so that is active or churn. This is a predicted value which I have here. That would the customer be active or churned out in future? I have created I've grouped customers into different parts. That's a completely random one. It does not have any relation. It's a random data which I've generated. So silver, gold, diamond, platinum. Silver is the lowest one. Diamond is the highest one. So a customer may be categorized as silver, gold, platinum, diamond. We usually, when we visit retail stores, they usually give us membership card that you can get a silver membership, you can get a gold membership. It's simply they are tapping you what you are doing. They are maintaining all those details, and based on that they are rating you. And then this is the label. This is the money I'm expecting you to spend with me. Okay, so don't look at it if it looks like a very big number. It's a completely random generated data. To be honest, what I've done here is I've put it as a 20% standard deviation with a weightage of 80% of monetary. If it's difficult, 80% of monetary value with a 20% of error, positive or negative, plus 15% of frequency with a standard deviation of 20% and error of 20%, and 5% of recency. So that's the mathematical equation they use to create this data. Okay, is the data understood, everyone? Any questions of data? I can create n number of features out of it, but because of time constraint I couldn't create, and I cannot show it right now. Okay, I'll quickly go to the code. I'll run this together. As I mentioned, Python has a lot of packages. I did mention that pandas and numpy, people should know it. We use it to store data into tabular format in Python and to process it, to make any changes. PyCaret is a nice library, although it's not used a lot, but PyCaret is a nice library in terms of AutoML. In this library, you just give the data which you have, and it will try and test out all the algorithms possible, and it would tell you that this algorithm is performing best. You do not have to check all the algorithms by yourself. Because Python, people have built nice package. And sklearn for model selection, someone asked me, is scikit-learn used? Yes, scikit-learn is used. So I'm splitting the data into train and test, because once I train on my data, I would test it to see if my model is doing good or not. I'm simply importing the data, the dot head return after data. I'm reading the data into transaction data variable and attribute data variable. The dot head function gives us first 5 rows of this particular table. Tables are here referred as data frames in Python. Okay, so I'm getting this. I'm just waiting for PyCaret to import everything a bit of time. Columns, select for training, table of 180 rows and 9 columns, table of 20 and 9 columns. These are the tables where the data is stored in this train, and my target is label. So I'm teaching label. I'm teaching this label, which is my CLV, I'm teaching this to the machine based on the data which is stored in train. What is in train? This one, recency, frequency, monitoring, total transactions, gross value, label and all. Is it clear? Any questions on this? It might feel a bit intimidating, but it's very easy once you put your hands on in Python. This is very easy one for you to look at. So I'm simply setting up the environment. It would see what all are the categorical features, what all are the numerical features. It would check all of that. It's just confirming that these are all the numerical features and all. You do not need to look at this. And this is the step where I'm training a model. It's so simple now. I've just said compare models. I've said already that I need to train on the train data. My target is label. I've defined it. Take all of the rest of the data for training. These are your features for you. And it is training all these algorithms on the fly in front of you. Just look at how many algorithms are there. And it's very difficult to cover all of these in a single talk. So the MAE MSE evaluation matrices. So you are seeing all of them. Pursuit. There's an algorithm named orthogonal matching pursuit. Performed well for me. People generate linear regression, random forest decision trees. So they are at here in the bottom. So I got to know that orthogonal matching pursuit is performing best for me in terms of RMSE, R2. These all are evaluation matrices. Don't get intimidated. Usually when we say how much percent marks you scored, that's a method to say how well you perform. So we have methods like MSE, RMSE and all. These are my evaluation matrices. I did train a model. I'm tuning the best model. This package gave me the best model out of it. When I did models, I got the best model from it. So it gave me orthogonal matching pursuit, maybe a Huber regression. One of the ones, I do not know what is the default set here. I didn't set anything. Give me the best tune. What is tuning of model is simply saying how how well to tune it to perform better. So if you build a car, if it's making a lot of noise, you do not need to rebuild a car. You may just need to fix some screws. You may need to tighten up some springs or things like that. We are just doing that. So I tuned the model. I have two references here, two inferences here. One is how well. So the diagonal line, the exact diagonal line which you are seeing is the line the model should have followed. But what linear line I've created is the one which is slightly off. And practically speaking, since this data is too much correlated, I've prepared it. This is a very well fit equation. Not see such good fits in your professional career. And then what are the most important features? So since I mentioned 80% of my label is comprised of monetary value. So monetary value has so high importance over the rest of the features. We can see all of these plots and all very well in Python. So I've taken help of a library which gives me all this. And then I'll just predict on unseen data. This is the prediction. So the actual value was this, which should have been predicted, and this is the predicted value. So at times you would see the value is very nearer. At times you will see the value is quite far in terms of percentages. So I've got my prediction, and R2 is residual sum of squares. It has this constant I had to. Any questions? No questions, be about anything. I'll end the topic here. Any questions which we have received online or something?
Which resources should I look forward or go?
Sorry, I didn't get the last statement.
Which resources?
Resources. You should know. You can look at any resource. If you want to start with machine learning, the EndRange's machine learning course is one. You can read blogs. You can refer any YouTube documentation, any YouTube video. Basically, there's a way of explaining. The one which you think is good, just or from the person from which you are understanding better, refer to it. For machine learning, you start with EndRange's course. That is my personal favorite. Learn Python, learn packages. of Python like pandas, numpy that would help you to speed up your learning. That's it. Any last questions about industries? How does software companies work? Anything about that, or should I end it here?
Which type of question interviewer ask from data science job role?
If you are a fresher, the people would ask you basics of ML, like what are the types, supervised, unsupervised, what algorithms are into which. They might ask you differences between bagging, boosting algorithms. If you're first year student, you might not know them. If you're third year, you might know them.
Yes, yes.
Bagging,
Third year.
third year. So bagging, boosting, random forest decision, very common.
Yes.
Questions. Linear regression versus logistic regression, very common. What is the difference? We use one for classification, we use one for regression. Even though the name have regression, then one is classification, one is regression algorithm.
Yes, yes.
Data processing techniques, what functions you have used, creating dummy variables out of it. Cleaning the data, pre-processing data. Questions on that. Your favorite ML algorithm, explain it. If you answer these questions, that person might go into detail like how does decision trees work, how does random forest. Usually that's what I've seen, that's what I have experienced myself. So I'll say that it sort of depends on how the organization is covering it. Okay, sir. I think you still have a doubt on this.
Yes, sir.
Explain it. What's the doubt exactly?
With DSM coding.
It is needed because a person to do everything. If I have to sort a data of let's say 500 MB and I've given it to you to write a code, if you are using a sorting technique which is not so efficient, it's basically costing us time or costing the organization when they are paying you for something. If you are doing a job in 1 week or if you are doing a job in 1 hour, it's efficient for any company that you're doing a job in 1 hour rather than 1 week. So data structures and algorithms is important. It's not that it's not, but it's important.
Okay, sir. Thank you.
Any?
Hello, sir.
Yeah.
So it was nice session.
Yeah.
So actually, just I want to ask, like all those who has enrolled in a data science as a course. So what basic course they should focus on, like apart from programming language, and if I say programming language also, so which programming language they should focus, like if it should be C++, Java, or if they learn Python only, it will be sufficient for them, or while interview, what the interviewers actually want from them, their knowledge, their skills, and like in computer science, we have lot many basic subjects like as per gate perspective or interview perspective that I know as per my knowledge, sir. Like we have operating system, we have database management system, then computer networks, kind of many course subjects are there. So is there any link between those core subjects and the data science? Means they should have some basic idea on those, means they should have to learn.
So, ma'am, this is a very this statement I'm not able to answer it very properly because I do not know what specific roles hiring person is coming in VIT.
Yes.
Do they come with specific role that I'm gonna hire only data scientist, or do they come that I want to hire computer science background people? If they are hiring for computer science background, they expect the basics like the data structures and algorithms, should write efficient code, should work, should use efficient algorithms, should create efficient algorithms if they know how do the algorithms work. That is one thing. Basics of database, even for a data scientist or be it any person, we expect them to write at least a simple SQL statement. If they do not know about that, if they do not know how to do joins, if in case it's needed that the person has to play a role, they should at least know basics of SQL, basics of data structures. I do not think that particular likeliness towards a programming language when people are being hired, if they are not for data science, generally widely accepted language is Python and R in data science, but Java person knows how to basically program, it's easier to move from Java to C++ or from Java to Python. The concept of programming should be there. If you know C++ or Java, it's good because those are more strongly typed languages. Python and all are very general language. It's very user friendly. They are not strongly typed. So people are likely to make more mistakes if they have learned Python and then they would have to work on Java. But they are likely to make not so many mistakes if they have learned Java and then they are working on Python. We do not have structures like int as a different, decimal as a different in Python. It's all numerical object for us. We can still typecast them into integers and floats, but when I create a variable, it directly goes to numerical format and not as an int and a decimal, and then we might get an error while running the code that you have given in decimal int in place of a decimal and things like that. So it's very general. Basics of everything is good, but if data science, the more likeliness would be that the person should know Python rather than more of a Java and C++.
Okay, so at the time of interview, when they will face interview for data scientists and all, so what they prefer, like only they should have idea of machine learning, deep learning, and data science, kind of these things. Like what I know, like for interviews, I heard this. I don't know actually. Normally they ask the programming language with C++ and Java. Even though if their company is working with Python, but at the time of interview they ask C++ or Java, kind of these things. So I'm a bit confused. Like if they will sit for data science interview, so they should be prepared basically with the data science only, or
Actually, what you have highlighted here is something which might be a problem of the industry. I do not want to term it in a wrong manner. Please do not take it wrong. It's not exactly problem, but I'm not getting an appropriate word. Our education system is designed in such a manner that people usually learn C, C++, and Java only in colleges. Agreed? Curriculum does not have Python everywhere. VIT might have it.
Yeah, we
but,
have.
But if I'm talking about my bachelor's, I had only C, C++ and Java in my curriculum. I didn't have Python. So a recruiter who comes to a college does not know what's your curriculum.
Okay.
That person is prepared in general sense. If all the engineering colleges are only teaching C, C++, and Java, that person comes with a mindset that this person should know at least C, C++, Java. And then the recruiter might not be from data science background. That's also possible until and unless they are specifically coming for data science role. If they are just coming for a software engineer, SDE, SDE1, 2, and things like that, the employees are expected to work in any field. I personally had to pursue my organization to give me a role of data science earlier. I was also being given a role of Java engineer. I showed them, I know it. There was luckily a vacancy in data science team, and then I got into data science. So it completely depends what they are gonna allocate you if you are a SDE, a simple software engineering organizations. So that's why it might be that the interviewer is more inclined towards Java, C, C++, or they have open positions for that thing. They might look for maybe HTML, CSS, front end, Angular, or things like that. So it's completely industry to industry dependent.
Okay. So to conclude is they must have the knowledge of database management system. Then they must be aware of Python and R, and data structures obviously.
Data structures, basics of OS, not maybe networking. That's not so important. Based on my personal experience, I'm saying basics of OS also helps. And basically whatever is being mentioned in general forums, I'll say that all is there.
In terms of programming languages, they must have logical skill.
Yeah, I've seen this personally. Interviewers don't exactly ask that you need to write code in C++ only.
Yeah.
They might say that okay, write it in Java or C++. Do not write it in MATLAB. If I come for your interview, since I have learned MATLAB, but I do not know MATLAB now, or I cannot recall codes of MATLAB. So if you write in MATLAB, that interviewer might not be able to judge you well.
Yeah.
that basically happens. Not everyone knows everything.
Yeah.
So that is a small thing.
So they just try to check the logics.
Yeah, they just try to check the logics. I gave an interview where, since the interviewer didn't know things, he asked me to write pseudocodes rather than codes.
Okay.
And I had to write pseudocode in front of him, and then he checked all the details for that.
Okay.
So it's something like that. That's it.
Okay. Thank you so much, sir.
Okay, thank you.
Thank you so much, sir, for such a skilled session. I hope it really helped us a lot.
So, you know what is stats?
Yes, of course, statistics. You can lie with stats, but you cannot tell the truth without statistics.
I hope you all have gained some knowledge and understanding from the session. So let's have a check on it by having a quiz. And yes, winners will get exciting prizes.
Yes, guys, quiz time. Be ready. Now, I would like to call upon the Vice President of the Data Science Club, Mr. Chetan Seni, to conduct the quiz.
So hello. So here we have the most interesting segment of this event, DATALIZE. So I will ask 15 questions from what you just learned in this talk by Mr. Archit Jain. I hope you have learned something new, and this is going to be a very basic data science quiz. So I will ask 10 questions, and whosoever will answer the maximum questions will get Data Science Club hoodie. And rules are simple. Those who will raise hands, they will get the first chance to answer the question. And that is 20 of the students are not eligible to participate. Not 20, not 19. Only for freshers. So volunteers, Mike. Okay. So you have to raise your hands. So first question is, classification and regression comes under which type of machine learning?
Supervised.
Yeah, correct.
Pulit Kaushik.
Which type of machine learning uses unlabeled data to train models?
Unsupervised.
Unsupervised.
Yeah, correct. Please write down your name. What's your name?
Divya Mathur.
Okay, so sir has not discussed this part, but this is a very basic question. What are the 5 V's of big data? Anybody? What are the 5 V's of big data? 20 batch.
Instagram, Facebook, YouTube, many social media platforms.
Actually, I have not asked this. I have asked what are the 5 V's of big data?
Variety, veracity, velocity, and volume.
4. Only 4 you have told. One more.
Volume, veracity, variety. Variability.
So the correct answer is volume, value, variety, velocity, and veracity. So this question was unanswered. No points. So it's a very simple question. Sir already told this. So machine learning is a subset of what?
Artificial intelligence.
Correct, correct. Name?
Rohan Mishra.
Okay, so next question is, in general, which algorithm is more efficient for regression in terms of evaluation matrix? Random forest or linear regression?
Linear regression.
Wrong answer.
Random forest.
Yeah, correct.
VIT Bhopal.
So, okay, next question is, predicting sales of a company is a regression classification problem.
Regression.
Correct. What's your name?
MD Amar.
Okay, so next question is, which measure of central tendency is robust against outliers? Anybody? Anybody know about outliers? What are outliers? Some students are raising hands. Okay, from 20 batch you can answer.
In a data set, if we have values that vary too much from the mean of that data set, and those values are like too much varied, so in a box plot they are visible quite very well. So the values that are too much varied from the mean of the data set, those are called the outliers.
Okay, correct answer. Please clap for it. So, okay, next question is, what do we call first layer of neural network? Okay, from 20 batch, anyone? Anyone?
Yes, here. Input layer.
Input layer. Input layer.
It is the correct answer. Okay,
Gauri Pandya.
okay, please clap. Support vector machine is which type of machine learning algorithm?
Supervised.
Okay, correct.
MDMR.
So it's going a very tight competition. So I will ask 5 more questions now. So now MDMR is like ahead with 2 points. Clustering is which type of machine learning algorithm?
Unsupervised.
What's your name?
Punit Kaushik.
Which method we use to determine value in k-means clustering? Which method we use to determine the value of k in k-means clustering? Anyone?
K nearest neighbors.
I'm asking which method we use to determine the value of k. Anyone from 20 batch? Slok? Here. Someone is raising hand.
Elbow method.
Yeah, correct. Which batch? 20.
Fresher.
Fresher.
First year.
What's your name?
Powers Goel.
Okay, please clap for me. So last 4 questions are remaining.
Those who please stand up and then I will come to you.
Which algorithm we can use to predict whether a person is going to have a particular disease or not? Stop that guy.
Supervised learning, linear regression.
Okay.
Punit Kaushik.
Sorry, wrong answer.
Random forest algorithm.
Yeah, correct.
Powers Goel.
What's your name?
Powers Goel.
Puneet Kaushik, please come here. MDR also, please come here. And one more. Paras Goel, you also come. So these three guys' points are like tied. So we will ask 3 questions here, last 3 questions, and sir will also join. And then we will decide the winner. You can also come on stage.
Only one question.
Okay, so there is the final question. So whosoever will answer from these 3 guys, that will be the winner. And sir will ask that question. Can we have some voting please?
So, should I take a question which I did cover in the slides, or should I take something else? Okay, people there are saying something else, people here are saying the one which you have covered here. Okay, so they've covered a lot of basics which basically I have put in. So let me go to a bit of jargons. Okay, if they were listening, they would be able to answer it well. What is the life cycle process? I've used a term for the data science life cycle. What is it? The entire term.
Crisp, cross.
Not the full form. Crisp is not the entire term. Okay, and the full form? Now since 2 people were
Crisp DM.
Full form?
Cross.
No problem. Something else. Because no one was able to answer it completely. Something else. I did talk about semi-supervised learning. When to use it?
Data is not completely there. When we have some parts of the data, then we predict what data is not present, and that's where we use semi-supervised learning.
We predict what data is not present.
Yes, sir. There are holes present. For example, you give the example of cat and dog. There are 3 pictures of dog, 3 pictures of cat, and then when we feed the machine, it learns what is cat, what is dog, and then it can do that process on unlimited number of pictures if it is cat or dog.
Not exactly correct. I'm not satisfied.
First we do unsupervised learning to classify them, and then we do supervised learning to predict the data that is provided, if it's belonging to a particular category or not.
Not exactly correct.
To find the abnormality or anomaly in the data, can you use semi-supervised learning?
No. The most correct answer was for the person who is in the center. Yeah, so I would say he is the winner.
Please clap.
Hello. So MDMR is the winner. Please clap for him. Congratulations, MDMR. Thank you so much, guys, for listening.
Thank you very much.
Wait. Whosoever wants to connect with Archit Jain sir, they can connect on LinkedIn. You can just search Archit Jain, you will find him.
You can search for Archit Jain, and to filter it out, search Zorient Solutions Private Limited. You might find 2 Archits there. There is a Archit K Jain and a Archit Jain. So make sure that you look for Archit Jain, and then you can find me easily there on LinkedIn.
Please wait. OD form and feedback form link is QR link will be there. So scan it and just fill it.
Yep.
Just 2 minutes. And we have another event at 2:30 p.m. today, the hands-on workshop on IoT data analysis. Please do come and enjoy.
Please scan the form and fill the form for
2:30 p.m. today in the auditorium.
Please scan the form for OD.
OD and feedback form.
And please fill the feedback wisely. Thank you very much.
Okay. Okay, you can go. Thank you so much.
Thank you so much, guys.
Do join us at 2:30 p.m. also.
गोपाल अभी स्टार्ट होगा ना